All right, we'll get started. As soon as it loads up here. Okay, Fire Streams, Chapter 16. So this is the one basically that follows all of our hose stuff, and it'll lead pretty well into everything we're gonna do for training on Tuesday.
Been interested in the subject since the beginning of my fire service career, but in my fire department in Oakland, California, we had a tragic line of duty death in 1999. Really sort of pushed me to delve into the subject farther. The Board of Inquiry report listed that as one of the three main causes of the death, and it caused us to really rethink what we were doing as a department as far as water delivery. And we've overhauled what we do for hose and nozzles, how much water we put on the fire. We've come to realize how drastic it is to deliver a proper amount of water, and that's what led me to get involved deeply in this. Led to meeting Andy Fredericks, being fortunate enough to learn a lot of things from him before he was taken from us on 911 at the Trade Center. Fortunate enough to be one of Andy's ambassadors around the country, trying to pass on what he taught us. And that's why I have a passion for the subject, and glad to be able to contribute what I can. Biased though I am, it is the heart of any fireground operation is what's happening at the business end, the nozzle. What's going on with the battle between the nozzleman and the fire determines how everything else on the fireground goes. Again, so many people have said it that once the fire's out, everything else becomes easier, safer, more efficient, and we're protecting the citizens and ourselves greater once we've put the fire out. Take up learning your job with a passion.
Okay. So an understanding of how fire streams operate is vital to extinguishment operations. The greatest life-saving action on the fire ground is the proper placement of the proper size initial attack hose line. As the first line goes in, so goes the fire. As the first line goes, so goes the fire. This lesson will introduce the student to the principles and applications of providing water at a fire incident, using the proper hose, nozzles, and appliances to effectively control an interior or exterior fire. Alright, so we've got a few sections here. Water as an extinguishment agent, nozzles. We'll talk about selecting the proper handline size. We'll talk about methods of fire attack. We'll talk about some different types of fire streams. We'll talk about advancing the charged hose line. We'll talk about positions on the hand line. Okay, so we'll start here with advancing the charged hose line. Hey Tristan, welcome here. Following completion, you can hear us, right, Tristan? He'll get there. The student should be able to describe or demonstrate the following: how the design of a pumper impacts the advancement of a charged hose line, by how well the dry hose line is stretched and flaked prior to charging is what's going to determine the efficiency and effectiveness of charging our advanced hose line. Or apparatus design influences the ease of stretching hose lines. User-friendly attack beds are low enough for the shortest of firefighters. Adequate trained personnel committed to the attack line significantly impacts the incident's outcome. All right, fire streams, positions on the hand line. Oh, hold on, something happened. Something way happened. Uh-huh. Yeah, I don't know how that happened. Oh, I clicked on one of those. Jeez. From current slide. All right, so we're back here. These are the rest of the topics. Sorry about that. That was weird. Hydraulic ventilation, we'll talk about. We'll talk about some hydraulic ventilation, talk about exposure protection, we'll talk about hose line use during salvage and overhaul, we'll talk about master stream devices, we'll talk about the care and maintenance of nozzles, and then there'll be a summary at the end. So, water as an extinguishing agent. Objectives for following completion, the student should be able to describe or demonstrate the following: development of fire streams over the past 150 years, determine specific heat and latent heat of vaporization, the importance of nozzle reaction on fire stream operations. Today's fire ground is much more volatile than in years past. There's more plastic in it, right? In years past, there would be typically Class A materials, stuff that would burn with a lot less intensity, whereas now most materials that we find in inside homes is more so made of plastic, which burns at a much hotter and a much faster rate. So flows of 95 to 125 GPM were adequate when fuel loads were lighter. Modern fuel loads are often hydrocarbon based and generate much more heat. Buildings are more insulated now and prevent fires from self-venting. So we have a lot more situations where the fires can be limited by supply of oxygen. Minimum flow rate for interior structural attack is 150 GPM. That's typically what we're going to get out of an 1 3/4 hose line. Many departments use a target flow of 180 GPM. Commercial occupancies require a minimum of 250 gallons per minute. The flow at which the GPM applied exceeds the heat released is called the critical flow rate, right? So sacrificing flow for maneuverability can be suicidal. Why use water? Water absorbs more heat than many other substances. 1 pound of water raised 1 degree absorbs 1 BTU. When converted to steam, it absorbs another 970 BTU. 1 pound of 55-degree water absorbs 1127 BTU. 1 gallon of 55-degree water absorbs 9,354 BTU. So that's why we use water. That, and it's cheap and it's plentiful and it's already there. Water expands 1,700 times its original volume when turned to steam, which is significant. We'll talk about that plenty of times over the course of our training. Steam can be useful in unoccupied spaces. Large quantities of steam can burn occupants and firefighters, and we'll experience that intentionally, not to the point of getting burnt, but we'll experience that heat increase once we get into some live fire training. Handling characteristics. Nozzle reaction is based on flow rate and nozzle pressure. So nozzle reaction is kind of like recoil on a rifle or a pistol. That's reaction that comes back towards you. That is based on flow rate and nozzle pressure. So the amount of water going out increases nozzle reaction, and the amount of pressure that's pushing that water out Kind of like the size of the bullet would increase recoil, as well as the speed of the bullet would also increase recoil. Increase either one, and the nozzle reaction increases. More than 75 pounds of reaction force is considered too much for a hand line. Less than 45 pounds of reaction force is a sign of an ineffective stream. So higher pressure makes hose stiff and less maneuverable. Highest flow for an 1.5 inch hose is 125 GPM. Highest flow for an 1 3/4 inch hose is 200 GPM. Again, that's 1 3/4 inch, that's what our crosslays are. So the highest flows for that hose is typically 200 GPM. A slight increase in size allows for much higher flows. They used to use 1.5 inch back in the day. So nozzles, the NFP standard that discusses the cause and care of a fire service, the design of a smoothbore nozzle, the design of a constant gallonage fog nozzle, the design of an adjustable gallonage fog nozzle. Those are all the things that we're going to talk about. The design of an automatic fog nozzle, and the operating characteristics of a smoothbore nozzle, as well as the operating characteristics of a fog nozzle. So nozzles control flow, create shape, and provide reach with our water streams. Um, but malfunctions will also limit the fireground effectiveness. Um, Early smoothbore nozzles. So this is basically what they started with, and then the original nozzles that we have at our fire station, um, they're all smoothbores. A lot of them are, 20 inches long, or at least one of them is. But that's where we all started with, was smoothbore nozzles. Shutoff was added over time, tapered tip for efficiency, and there was many configurations. So the orifice, which is the outlet size, should be 1/2 the hose diameter. So if you have an 1 3/4 inch hose and you have one half of that 1 3/4 inch would be what, 7/8? Sounds about right. Yeah. Exceptions have been made, such as a 15/16 on an 1 3/4 inch hose. So what we use on ours is a 7/8 tip. That's pretty much the standard for an 1 3/4 inch smoothbore tip is a 7/8 tip. That's why you'll kind of hear that as for the most part that's what we use. 15/16, I think that's a New York thing. Early fog nozzles were first developed in 1863. They gained widespread use after World War II. Small droplets of water dispersed in a pattern. Droplets evaporate more readily, generating steam. That's just simple surface area, right? Pattern can adjust from fog to straight stream as far as current smoothbores nozzles are the most low-tech nozzle. They're compact and lightweight. They only produce a solid stream. They're low maintenance. They only have one moving part, and that's the bail. And they're very difficult to clog because there's no holes that the water goes through that's smaller than 7/8. Fog nozzles used for interior fire attack must use the straight stream pattern. So you will notice that most of our crosslays, one of them is set up with a fog nozzle and one of them is set up with a smoothbore. You'll find situations where people will they'll pull the fog nozzle or the combi nozzle for some structure fires. So just make sure that if you're using that to fight an interior fire, that you have it on straight stream, which is if you have it in your hand, you have it turned all the way to the right to fight, and that will put that nozzle in a straight stream so that it's still safe to use. Constant gallonage fog nozzles are the simplest and most reliable of the fog nozzles. Flows a specific gallonage when operated at design pressure and possibility of introducing a fog stream into the fire area. So they use some different valves and plungers and stuff in there to get the flow rate correct. Adjustable gallonage fog nozzles. Selector ring adjust flow setting. Possible to set the ring on the wrong setting, and pump operator must be notified if the flow is changed. We don't have any adjustable gallonage um, on ours. Automatic fog nozzles, baffle and spring arrangement. The stream reach and appearance looks like a 100 psi tip regardless of the pressure. Orifice opening changes depending on the flow. Pressure is maintained around 100 psi. Um, so it'll put more pressure on that hose stream to continue to get the reach that you would if you're pumping it at 100 psi. Smooth bore nozzle.
Hold the nozzle so that the bail is at arm's length while maintaining a secure stance. Open the water supply by pulling the bail toward you.
Hmm. I'm not sure if I can.
Turn off the nozzle by pushing forward on the bail. When shutting down the water to the nozzle, do it in a slow, smooth motion to reduce the water hammer effect.
Hmm.
Hold the nozzle so that the bail is at arm's
Any better?
length while maintaining a
Oops.
secure stance. Open the water supply by
about all I
pulling the
got.
bail toward you. Turn off the nozzle by pushing forward on the bail. When shutting down the water to the nozzle, do it in a slow, smooth motion to reduce the water hammer effect. Hold the nozzle so that the bail is at arm's
Okay.
Hold the nozzle so that the bail is at arm's length while maintaining a secure stance. Open the water supply by pulling the bail toward you. Rotate the nozzle to the left to widen the fog pattern.
It's quiet for me too.
Rotate the nozzle to the right to make the stream more narrow. Turn off the nozzle by pushing forward on the bail. When shutting down the water to the nozzle, do so in a smooth, slow motion to alleviate the water hammer effect.
Okay.
Hold the nozzle.
Whoa. Selecting the proper hand line size. Following completion, we should be able to select the proper nozzle, and we should know the acronym adults. Typical room and content fires can be handled by 1.5 inch, 1.75 inch, or 2-inch lines. Commercial occupancies require the use of a 2.5 to achieve the needed flows. The 2.5 inch hand line. Smaller hand lines cannot duplicate the volume, reach, and knockdown of a well-placed 2.5 inch line. Exceptional penetration and little premature water vaporization. Just like rifle calibers, sometimes there's just no replacement for a larger piece. Simple mnemonic to use is adults. A. Advanced fire on arrival. D. Defensive operations. U. Unable to determine extent. L. Large open areas. T. Tons of water. Or S. Standpipe operations. These are all situations of when we should use 2.5. Heavy fire found on arrival requires the use on 2.5 inch hose for rapid control. Extensive fire found in private dwellings may require the use of a 2.5 inch hose. Attack can transition to smaller lines after knockdown. Greater reach allows it to be operated outside of the collapse zone, which is also important. Larger volume has a greater effect on the fire conditions. Obviously, the more water that you put on the fire, the faster that's going to cool the fire down. So allows for unforeseen conditions that may be encountered. So if you have the biggest tool in your hand, then it gives you the most options if conditions get worse. So reach and penetration are needed for large buildings. High ceilings allow high heat to collect at ceiling level. These are large non-compartmented areas, so like a grocery store. High ceilings allow heat to collect at the ceiling level, allows operation from the entranceway into the area. So, big thing with that is the roof collapsing. Tons of water. I have to go get some cough drops here in a second. Junkyards, dumps, lumber yards, etc. require large volumes of water. Smaller lines would be ineffective. There's obviously if you have the fuel load that requires more water, then you're going to need a larger hand line to get that water out there. NFPA 14 was based on the use of 150 feet of 2.5 inch hose equipped with an 1 1/8 tip. Outlet pressures can either be 65 psi or 100 psi depending on date. These are for standpipe operations. Sorry, I keep missing those titles. Pressure reducing valves prohibit the fire department from adding needed pressure. So standpipes, if you guys don't know, it would be like it's a pipe that is plumbed into an apartment complex or larger buildings, and then you can that pipe may feed the sprinkler systems, and it may feed like different hose line uh, hookups inside the building. So you can hook the truck into it outside on the ground, and then you can carry up a single roll of 1 3/4, and you can hook it up on the 5th floor or something like that, and you can take off with it there. So generally you want to pump those pretty hard. All right, watch this video here.
Locate a standpipe in the stairwell, one floor below the fire floor. Check that all pressure reduction devices have been removed from the standpipe. Attach the female fitting of the hose bundle to the male fitting on the standpipe. Flake out the appropriate hose length, advancing it to the door of the fire floor. Charge and bleed the line prior to entering the fire floor.
Okay, so that's their standpipe operations. All right, methods of fire attack. Following completion, we're going to understand the indirect method of fire attack, the combination method of fire attack, the method of direct fire attack, the method of a modified direct fire attack. So the indirect attack method was originally developed for combating shipboard oil fires. Steam created is the major factor in extinguishment. Steam occupies 1,700 times the volume of liquid water. Smoke, heated gases, and other products of combustion are displaced by steam. Steam absorbs heat faster than water can cool combustibles below their ignition temperature. So an indirect attack would be if we are going to be hitting the fire from outside of the building. So the fire would be inside the room, just like the picture here, or just like that fire that you guys had out there on Colorado Avenue. Um, the fire was inside the building. You hit it through the window, I believe, and then after it got the initial knockdown, then you were able to make advancement in and continue to hit it. So that would be like a combination attack. But that initial would be indirect attack because you're outside the house, the fire is inside the house. So water fog is remotely injected into an unoccupied compartment. Unoccupied is the key there. If there's people in there, whether they're firefighters or civilians, you know, uh, you don't want to fog them out there because that will increase more steam, and then it gives obviously potential for steam burn. These conditions must be met for an indirect attack. There must be no life hazard in the compartment, including firefighters. Ceiling temp must be at least 1,000 degrees Fahrenheit. Water fog must be remotely injected from the exterior with no ventilation. If these conditions are not met, a direct attack is needed. Fog stream directed through a window or door. This is a combination method of attack. Um, so you're directing a fog stream through a window or a door. Rotate the stream clockwise, hitting the ceiling, walls, and floor, and we'll talk about sweeping at some point here. No life hazard can be within the department, again, because we're using a fog stream. Ventilation should be limited to take advantage of the steam. Ceiling temperatures must be at least 1,000 degrees Fahrenheit. So, not typically stuff that we do. For the most part, we fight everything with a straight stream, which is a direct method of attack. Application of a solid or straight stream directly burning on the fuel. Used when the fire is relatively small, preserves the thermal balance of the fire compartment. So we haven't talked about thermal layering yet or thermal balancing yet, but as that heat rises, or as that fire creates heat, heat's obviously going to rise, basically thermodynamics. That all that heat is going to build at the ceiling, and it's going to slowly keep building that heat from the ceiling down as it brings more and more heat into that compartment space. So if you use a fog pattern, it can disrupt that thermal layer, and you can bring all that heat from the ceiling, and you can push it down to your level where you're at, and it'll raise the temperature very, very quickly. So you don't want to disturb um, that thermal balance in there, or that thermal layer. Modified direct method of attack is two-step attack. Application of a solid or straight stream overhead and out in front, moved clockwise or side to side. The steam is then directed onto the solid burning fuels. So this is the most common method of nozzle sweep or nozzle attack that we will do, and this is probably the one that you'll spend the most time practicing is to make it muscle memory. But as you advance, you'll sweep the ceiling. You might, and everybody will do it different. Some people do a horseshoe, some people do big circles, but you want to sweep the ceiling, sweep the sides, and work your way. You sweep the floor, and then you work your way in, advancing towards the fire, and then eventually you'll put the water on the fire, but always with a straight stream. That's important. And we'll put that stuff all hands on Tuesday. So the benefits of a modified direct attack: cools ceiling level, preventing flashover. So we want to cool off that water in the ceiling. And again, just to reiterate, if we were using a fog stream while we were cooling that ceiling, since we have a larger surface area that's hitting all those gases up there, um, it's going to displace those hot gases. It's going to push those hot gases around the room. Whereas if we do it with a solid stream, it's going to basically penetrate through the gases, and it's going to cool the surface of the ceiling. So it's going to penetrate through the gases without pushing the gases around, and it's going to hit the ceiling and cool off the surface area, which is what we're trying to do. We're not necessarily trying to cool off the air. That's the part that we want to stay in place, if that makes sense. So drops water onto burning solid fuels. As it hits the ceiling, it rains down the water onto the stuff that's burning on the floor and the walls. The Blitz attack, developed in the 1970s, a swift knockdown of a large quantity of fire that is rapidly spreading on the face of the building. So choosing a method of attack, the transitional attack. It is important to point out that the transitional attack does not take the place of an interior attack. The transitional attack is intended to temporarily slow the fire down with rapid follow-up with an interior attack. I guess this would probably be better terminology for what we typically do, like we did on Colorado Avenue, would be a transitional attack. We would transition from an exterior attack to an interior attack. Fire stream types. We're about halfway, so I'm gonna go grab some cough drops so I can stop coughing in you guys' face here. Okay. By the end of this, we should understand the three types of fire streams. Solid. Okay, there are three main types of fire streams: solid, straight, and fog. So all will extinguish a fire if applied long enough with sufficient volume. Smoke can make conditions in the fire compartment worse. Oh wait, some. Fog streams. Scalding steam is created. The biggest problem with fog streams is that they put off a lot of steam. Thermal balance is disrupted, like we've talked about. Fog nozzle ricochet causes heat and gases to roll over and around the nozzle team. So we talked about that, right? Pretty much beat that one. Solid and straight streams provide a greater stream reach, obviously, just like your garden hose, and it allows firefighters to attack the fire from a greater distance. Studies have shown, given equal fuel loads and flows, solid streams extinguish fire faster. Solid streams require less water to achieve extinguishment. Solid streams have less measurable runoff than the fog stream. Advancing the charged hose line. Following completion, we should understand how the design of a pumper impacts the advancement of a charged hose line. Efficiency and effectiveness, here's where we skipped up to, determined by how well the dry hose line is stretched and flaked prior to charging. Uh, as far as the hose beds go, we've talked about our hose beds a few times now in our past chapters, but apparatus design influences the ease of stretching hose lines. User-friendly attack beds are low enough for the shortest of firefighters. Staffing is important because the adequate trained personnel committed to the attack line significantly impacts the incident's outcome. Sure. Okay. Uh, Positions on the hand line. Following completion, we should be able to understand the responsibilities for the engine company officer on the hose line, the responsibilities of the nozzle operator on the hose line, responsibilities of the backup position on the hose line, and the responsibility of the door position on the hose line. Engine company officer, he's overall responsible for the operations of the company or the group. Staffing levels may allow an officer to supervise and not take part in handling the line. Avoid tunnel vision if needed to assist the hand line. Okay, those are all things that we work on. You know, sometimes you will have somebody that is we will have 3 or 4 people on a hose line. It just kind of depends on what we have going on. So, but a lot of times, usually we do it too. Company officer reconnaissance. Move ahead of the company during advance. Direct company to the correct route, determine forcible entry problems, perform search ahead of the line, and confine the fire by closing a door. So it is possible that we will have a team, usually of 2 people, that are in there searching ahead of the hose line. They may even go in before the hose line's even charged. The first thing they're usually going to do is locate the fire. If it's in a bedroom or if it's in something where they can close the door, they can isolate that fire. Helps kind of limits the oxygen that's getting to it and limits the spread of the fire. And then it allows everybody to have a little bit more time. And then they're going to tell the hose team the best way to get there, and then where it's at, and if there's any special needs. And they're usually going to continue the search after that. So avoiding hose line stretch mistakes, locating the fire before stretching. Avoid these mistakes: stretching short or long, stretching to wrong location, stretching to the wrong floor, stretching via wrong stairwell, and stretching to the wrong building. So typically you want to have a pretty good idea of where you're taking that hose to before you just start running it through the house. Otherwise, you may find out that you're just creating more work for yourself. Chalking doors. Most of us should carry some sort of something that we can use for door chalks. Hopefully it's something cheap, not a $50 or $60 tool or something, because they will get left behind. Doors become hose clamps. All doors the line passes through must be chalked. Doors closing over a dry line act like a hose clamp when charged. So If the hose, they're talking about if you stretch the hose in without it charged for whatever reason, and it slides underneath the door, um, because the hose is flat, and then once you charge that hose, there's no way that it's going to be able to lift that door up enough to fully charge that hose. So just make sure that you um, don't have that kind of problem going on. It will also lock the door shut. It's a good point too. Stretching dry hose lines. So a dry hose should be stretched as far as possible for speed and ease, especially if you're, stretching hose up along a long area. It's going to be a lot easier to do it without water in it. Charge before entering the fire area, though. Obviously, you don't want to try to go entering the fire area without having a charged hose line. And then whenever you charge it, it's going to blow out a lot of that air, and so you're just pushing air onto the fire. So make sure that you charge it before you enter wherever the fire area is at. And it's not uncommon. I mean, it seems like what we all think about is, single-family dwellings. But if you have an apartment complex and you got to get to even the second floor, like you're probably not going to be uh, charging a hose and then dragging it up all those stairs and then dragging it down to the apartment that's on fire. So it's definitely good stuff to know. Properly flaking hose before, oh yeah, so stretching dry hose lines still. Properly flaking hose before charging prevents kinking. So before we charge it, we just want to make sure that we walk everything out. We make sure everything's flaked out like it should be, or it'll just be more difficult once we charge it. Notify pump operator to charge the line only after it is properly flaked out. Bleed all trapped air from the line, like we talked about. Open the bail, push all the air out till it's nothing but good solid water. We don't want to push that air onto the fire. Officer's senses. So look for the condition and extent of the smoke and fire. Listen for victims, crackling of fire, breaking glass, or signs of collapse. Feel for changes in the heat. So the things that we should all be paying attention to. Doors to the fire area. Open on arrival. Look under the smoke for victims. Lay out obstacles and fire. Once the nozzle is open, visibility will be lost. So doors that are closed on arrival, nozzle team should be positioned to the side of the door, and the location depends on the door swing. Okay. So if the door's closed whenever we get there, you just make sure the nozzle team is in place and ready to fight fire before you open it. There's no reason to open it prematurely. After opening the door, stay low and let it blow. Allows pressurized smoke to vent and it allows smoke to lift. So you're letting that air come in down low, and it's going to be able to push the smoke up. It's going to get cool air in there. It's going to allow for a more defined thermal layer. You see here when this, yeah, I assume that there was a different door that they opened, but it's kind of hazy in there. It's kind of a little bit less defined because all that this air has all been slowly heating itself to be about the same temperature. Whereas once you open a door, you're introducing air that maybe 40 degrees, 50 degrees, and it's going to rush in and it's going to put a very defined thermal layer, which should kind of help you be able to see underneath that smoke a little better. Changes in thinking. Older saying told firefighters, don't put water on smoke, wait until you see fire. So that's what everybody used to fight fire with. Um, Modern fuels give off hot, fuel-filled smoke and must be cooled. Now we're to the point where it's so much more common for the smoke to be so dense with flammability and oil. I mean, it's so black smoke that a lot of times that smoke is flammable enough to where we need to cool it off just to prevent uh, more likely flashover situation than there used to be. So flashovers are a lot more common now just because the smoke is statistically more flammable. observing smoke conditions. So thick black smoke is laden with fuel, like we talked. Um, Rapidly moving smoke indicates high heat conditions. So if you have that smoke that you can just see it just, pushing out like it's coming out of a chimney on a freight train, you know that there's a lot of heat behind it that's pushing it pretty hard. Black fire is heated fuel that only lacks oxygen to burn. So black fire is basically just, thick black smoke. And the only reason that it's not on fire is because it needs a little bit of oxygen. And so whenever you open that door, that could be the oxygen that it needed to quote unquote flash over or backdraft or either way explode or burn quicker. So let the water do the work. Use the reach of the stream to begin attacking the fire sooner. Um, Sweeping the ceiling with copious amounts of water kills the potential for flashover. So that's why it's really important that's where we start. We start sweeping that ceiling down because the flashover is for the most part, that's the most dangerous fire detriment to us as firefighters is the flashover situation. Um, and so we want to make sure that we cool that ceiling down any chance we get. If we see thick black smoke up there and it looks like it's hot and it feels like it's hot, just start cooling it down. You won't hurt anything. That's kind of always be cooling. Then we'll go on to cooling the floor. So sweep the floor ahead of the advancing team. Cools runoff, clears debris, and can indicate floor collapse or stairs ahead of the team. So as you sweep the floor, like I said, it's cooling everything off a little bit for sure. It clears off all the shit that's on the floor or whatever. But it can also give you an idea of the condition of the floor, and it can help you see if there is anything that's going to open you up to a dangerous situation. So it has multiple reasons for sweeping the floor. Nozzle operator, always bring a working length to the fire area. Flake out before charging and entering the fire area. So you always bring that coupling with you, and that's why a lot of the hose advancement and hose pulling stuff that we go over on Tuesday, that's going to be the general. That's going to be kind of a common theme that you'll hear is to grab the nozzle and a coupling and have both of those at the door. That gives you a 50-foot section of working length that you have to advance with from there. And so that's what they're talking about here is making sure that you don't just stretch that hose out. Especially, back in the day, they would run just a regular old flat load, and they would stretch that hose to the door, and that would be all the hose they would have, and they would charge it, and then they would have to pull all that hose from the yard or wherever, because they didn't bring any extra hose with them to get inside the building. The backup person is most of the work in the nozzle team is done by the backup firefighter. The goal is to make the nozzle operator's job as easy as possible. So he's pushing on the hose. He's working against that nozzle reaction, working against that hose reaction. He's trying to manage, pushing the hose forward as they advance. He's managing kinks. He's managing the corners. They're doing everything they can to make sure that they're getting that hose to the fire as much as possible. And the guy in the front, he's sweeping the ceiling, he's sweeping the floor. He's got plenty of work too. The last thing that he also should have to be doing is carrying the load of that hose and the load of that nozzle reaction. So that's why the backup guy, his primary job is to take as much workload, as much weight off of that guy in the nozzle as he can. All right, nozzle team operations, handling the nozzle. Do it.
Determine the number of corners to be gone around. The nozzle firefighter and backup firefighter lead the way. Leave personnel at each corner while advancing, starting with the last firefighter in the hose crew. stay on the outside of the hose bend, keeping hose between the person and the corner so as not to be pinned. When retrieving the charged line, the nozzle firefighter stays with the nozzle and the line is walked out in reverse of how it was advanced. Determine the
So, applying the stream.
While advancing in a fire, make sure to sweep the floor to push debris away from you and cool the floor to help avoid burn injuries. Rapidly moving the stream pattern side to side off the ceiling helps to distribute water droplets to the fire area.
You're just sweeping the ceiling, sweeping the floor. Like I said, some guys will sweep the ceiling in a horseshoe and they'll sweep the walls too. But biggest thing is making sure that the ceiling gets swept as you advance, and the floor, so that you're keeping some situational awareness down there.
The clockwise pattern of stream application is an efficient method for extinguishment and lessens the burden on the nozzle operator. While
So advancing with one knee up.
firefighters can advance the line with one knee up. This resembles a shuffling motion. Firefighters can advance.
Or the duck walk.
The duck walk is a position resembling a duck. Squat, remain low, and move forward without placing a knee on the ground. This is an effective way to avoid burns and injuries to the knees.
Yep.
The duck walk.
Okay, so the backup person does most of the physical labor in the nozzle team. He's dragging the hose, he's pushing it forward, he's doing everything he can to help out. He's on the same side of the hose as the nozzle operator. That is important. You do not want to have both those guys on different sides of the hose. So whichever side of the hose the nozzle operator's on, the backup person should move to the same side. Keep a straight line behind the nozzle operator and provides forward momentum. So he's the one pushing forward when it's needed. Move opposite the nozzle operator. So if the nozzle is directed to your left, you move right. So if that makes sense, the guy on the nozzle, if he's trying to aim to the left, then the guy behind him wants to swing that whole back of that hose out to the right, because that hose wants to stay straight. That makes sense, because you're wanting to pivot that whole hose. So if the nozzle guy is trying to push it to the right, you want to move the back of that hose out to the left to help straighten that hose out, to line it up. Does that make sense? If the nozzle is directed down, you lift up. So if he's trying to aim it down and he can't quite get it, if you lift the back of that hose up, it's gonna point it down. The door position. This is usually the third guy. He will ensure smooth movement of the hose He's going to help manage it at the door. If there's a sharp turn, maybe they're going into a hallway, he will go in that far. Maybe they'll put another guy at that sharp turn, um, just to make sure that any of those tight pinch points get managed. It eliminates any kinks in the hose line and an essential job that must be performed. So sometimes we may have to have the engineer do this part. I mean, but it's definitely got to get done by somebody. Somebody's got to manage that hose from the outside and make sure that they're getting, if they need more hose pushed in there, that they're at the door, main door, they're pushing it into that house, and then the other two guys are dragging it wherever they need it to be. But somebody's uh, got to be feeding it in there. Duties of the door firefighter: avoid the tendency to move up the line to the nozzle team. You know, everybody wants to get in there and help fight fire, but like I said, somebody's got to stay out and manage that stuff. Arrange the hose in the front yard or sidewalk for ease of advancement. So get it zigzagged out, and we'll talk about that, and we'll talk about different ways to lay it out on Tuesday to make it easier for everybody else. We kind of pre-plan that a little bit. Push enough hose to keep the nozzle team moving, but if you push too much hose, it can create kinks. So if you push in too much hose, then they just got a spaghetti mess in there that'll be harder to work with. So move back and forth between the door and one length behind the nozzle team. So you want to try to chase, you want to try to chase that hose basically in an area where the nozzle team doesn't have any effect over it. So if they get real in real deep, you might have to go in there, a little ways to try to manage that hose for them around different pinch points like we talked about. Door firefighter loops. Arrange excess hose in loops to reduce kinks. Keep the hose straight as, as it enters the door. So, um, we just want to make sure that we're managing that excess hose in an efficient manner until it's used up. But we do want to make sure that as it goes into the door, that it doesn't have to take a hard bend to get into the house. So that's why we want a good straight line going into the door, like we talked about with our when we were doing our Guston packs the other night.
Determine the number of corners to be gone around. The nozzle firefighter and backup firefighter lead the way. Leave personnel at each corner while advancing, starting with the last firefighter in the hose crew. Stay on the outside of the hose bend, keeping hose between the person and the corner so as not to be pinned. When retrieving the charged line, the nozzle firefighter stays with the nozzle and the line is walked out in reverse of how it was advanced.
hmm
Determine
Advancing charged hose lines upstairs. Charged hose line loop method.
the nozzle firefighter and backup firefighter lead the way. The firefighter near the doorway lifts the hose above their head and makes a twist, thereby creating a loop in the hose. As more hose is called for, the loop is rolled forward, and if the team backs up, the hose is rolled backwards.
This is not something I've practiced.
The nozzle
Okay. Extending hose lines. So underestimating a hose stretch may require firefighters to add hose. Some nozzles can be shut down and hose added to the threaded tip. Now we can do that with ours, like we talked about. That's how our Guston packs are set up inherently. It's how we keep them set up. But all of our nozzles can do this. Okay, and we'll talk about hydraulic ventilation. This is the procedure for venting with a fog nozzle and the procedure for venting with a smoothbore nozzle. This is useful to know. You'll probably use it um, quite often in your career. We use it pretty often, just because it's convenient. It's already in your hand. But water directed out windows or doors to exhaust smoke, heat, and gases. So is hydraulic ventilation. In some cases, the fog nozzle works better than fans. Um, quick and easy to employ after a knockdown. So nozzles for hydraulic ventilation. Fog nozzles work best because the stream can be adjusted to fit. Smoothbore nozzles can be used by rotating the stream within the perimeter of the window. So the general idea, I assume that they'll talk about it, but then again, they may not. But the general idea is that if you have a room that's full of smoke or heat or whatever it is that you're trying to evacuate out of it, um, like he's doing here, you want the window that you have broken out. You want the water that you're spraying out that window to encompass as much as the open surface area of that window as possible. So if you fill that whole window with water that's going out, then the Venturi effect is going to draw in all the air and the hot air and the gases and the smoke. It's going to draw it out that window with the water that you're forcing out of there. And so because of that Venturi effect, it's very effective in removing gases. But if you have a big window and you shoot that window with a solid stream, you're not going to get enough of a Venturi effect with that solid stream in that big window to really move much for smoke or heat. So you need to adjust your pattern to where you're shooting water out as much of that opening as you can. That's why the fog nozzles are easiest, because you can adjust that fog nozzle pattern to take up that whole window, and then also adjust your distance to that window. Maybe you're 6 feet away from the window, maybe you're 10 feet away from the window. Um, Safety. Monitor smoke and heat conditions while ventilating. They should be getting better. Fire can reignite and grow when fanned by air currents. So just like any other ventilation, if you don't have the fire out very well, you could reignite the fire by doing this. Other uses: direct gas vapors away from exposures or life hazards, like in our propane situations. You can use the same concept well, not really the same concept, but it's a similar concept to kind of push back those propane gases so that you can get in there and turn that valve off. But yeah, I didn't really talk about it. So um, we will we always train on hydraulic ventilation quite a bit, but um, we'll do it on Tuesday as well. But like we said, the fog nozzles are easier because you can adjust that pattern. But if you are doing it with a smooth bore, that you can basically, what you do is you only open that bail maybe halfway or so. And what that does is it breaks up that stream into a real sloppy fog pattern, which still kind of works, and maybe you open it all the way and then you close it a little bit to where maybe you get a small fog pattern, and you just have to stand, instead of being 6 feet from the window that you're pushing out of, maybe you're 10 or 15 feet back. That way you can try to gauge it that way. So you can definitely do it with a solid stream. You just gotta kind of play with that bail a little bit. All right. Exposure protection. Following completion, we should know the different methods of protecting exposures. So, exterior exposures must be protected. So, an exposure is basically if we have a house that's on fire, the exposures are typically adjacent buildings or vehicles or campers or anything else that's exposed to that radiant heat. So that's what we want to protect. Protect adjacent buildings from convective or radiant heat. Radiant heat can travel through fog or water. Water must be applied directly to the surface of the exposure. So you don't want to, it won't do any good to shoot it between them. You need to hit the actual surface of the exposure that you're trying to protect. Exposure hand lines, just like anything else, larger provide adequate water for cooling and extended reach. Position out of the collapse zone. There's no reason to be in the collapse zone to do a project like this. And we'll talk a little bit about collapse zones. But we'll talk a lot about collapse zones in some later chapters. But basically, the safe point to be on any building, if you always remember that at the corners are the strong points. So if you can be off, at a 45-degree angle off the corner of a building, you're not in the collapse zone. So, um, you always want to kind of have that in the back of your head that the corners are the safe points. Okay. Hose line use during overhaul. We're going to talk about the importance of proper fire stream use during overhaul. So after the fire has been extinguished, hose lines should be in place in any area where there has been fire damage. Water use should not be excessive, and look for structural damage while overhauling. So we want to make sure that even though we have the fire out, that we still spend the extra time and we're patient and we wait to see, what's not out all the way yet, what's still smoldering a little bit. You guys have been on enough structure fires right now to really understand how we do that and how important that is. But you guys, I don't think have been to a rekindle yet, so you don't know what that feels like. Nothing is worse than going to somebody's house and having a fire and putting it out and having to get called back 8 hours later at 2 o'clock in the morning and the fire's done more damage than it had when you left. So that is terrible. You don't want that to happen to you. But the water use is not necessarily the answer. You don't want it to be excessive because you can easily do more damage to somebody's house by flowing excessive water than the fire does. Also, look for structural damage while overhauling. You want to kind of help and recon that stuff. Understand if there's some failure points in the trusses or in the floor joists or some of those critical structure elements that we can try to determine if there's a pretty serious problem here that we need to not let these people be in this building or something. So overhaul safety, never leave a hose line unattended during overhaul. That will happen quite a bit. Flames can rush out while walls and ceilings are being opened. That can happen also. So as you're pulling sheetrock, you could a lot of times you'll find a hot spot and flames can come out at your face. So pay attention to that. Nozzle can be buried in debris while overhauling. So try to take care of your tools. Axes, Halligans, you may lose them and never find them again if they get buried in sheetrock. All right, master stream devices. You guys are familiar with ours by now. The minimum flow of a master stream device. We're going to talk about the types of elevated master stream devices, the difference between a deck gun and a deluge gun, the uses of a piercing nozzle, the uses of a cellar nozzle. So defensive operations, no living people, included firefighters, can be inside the building when used. Okay. Flow greater than 300 GPM. So the deck gun, our blitz line, um, those that flow a lot of water. Large quantity of waters can be dangerous if misused. It can definitely hurt somebody. Manufacturer's recommendations. Do not operate outside of their range of elevation and lateral movement. Talking about deck guns here, so don't hit the side of the truck. Um, don't hit people on the ground. Nozzle reaction is substantial. Um, don't try to pick up that our ground monitor and try to advance it while it's flowing water because it's not like hanging on to a nozzle. Ladder pipe, apply water from above, may be detachable or pre-piped. So we don't have anything like this except for what's attached to our platform on our tower, but they can definitely move an unfathomable amount of water. Tower ladders, we have one, we're getting a new one. Mounted water monitors controlled from the platform. Powerful streams can knock down walls. They most certainly can. You do need to be very, very careful with these because you can do a lot of damage. Deck guns mounted on engines and maybe detachable. 920 has a deck gun on it that looks almost identical to this. Quick knockdowns may be moved to a location on the ground. The one that's on 920, we can quick detach it. And then we have a ground monitor adapter to where we can move it down to the ground and use it as a ground monitor. Rotating wheel and locking devices move and secured in place. Bases must be chained when operated from the ground. Now, I don't think we chain ours, so we probably ought to. Deluge guns, portable monitors that are always used on the ground. So this is like our ground monitor. What do we call that thing? Some name for it. I always forget. The back of 921. Yeah. Yeah, the RAM. I think that's what people call it. Yeah, that thing.
First, remove the monitor from the apparatus and position where it will be used. Position the monitor inlets so they are facing forward towards the fire. Stretch a sufficient length of hose from the pumper discharges to the monitor inlets. Cross the hose in front of the monitor so the hose coming from the left goes into the right inlet and the hose coming from the right goes into the left inlet. Where the hose links cross over one another, tie them together with a rope, hose strap, or webbing to provide additional stability. Once the hose is connected to the inlets and the monitor is secured, notify the pump operator to open the discharges in a slow and deliberate manner to avoid water hammer.
Yeah, I'm not so sure that we have any that take two hoses, but that would sure be sweet.
First, remove
Specialized nozzles. So piercing nozzles apply water to hidden spaces. We do use piercing nozzles quite often. Typically at Pawnee, we use piercing nozzles in all of our, not all of our, but most of our coal fires. We'll get the piercing nozzle out, and that allows us to penetrate into that coal. Maybe it's 20 feet down, maybe it's 30 feet down, and kind of try to put that water where it needs to go. Distributor nozzles, basement fires when normal attack is not possible. Yeah, I'm not sure about those. I've never used anything like that. Cellar pipe, directed stream pointed in any direction by a lever. Also pretty cool. Not something we will ever have. Care and maintenance of nozzles. Almost done. Do not drop or throw nozzles. That should be obvious. We want to take care of those things. We have very nice nozzles on our department, and we should take care of them because they're cool, and we want them to continue to work well for us. Keep nozzles fully operational. Inspect the following: waterway clear of obstructions, bail works properly, no dents or nicks in the tip, and no missing parts or worn out gaskets. So just like anything else, we always want to check the gasket. We always want to check the bail, make sure that it works smoothly, that there's nothing that's chipped in there that's causing it to bind up. If everything looks like it does. Okay, and in summary, um, we use water as an extinguishing agent. Yep, we learned that tonight, I guess. Nozzles, selecting these are all the things we were supposed to learn. Selecting the proper handline size, methods of fire attack, fire stream types, and positions on a line. We talked about so water is an extinguishing agent because it's cheap. It absorbs heat very well. We talked about the different types of nozzles, smooth bore, solid stream, or smooth bore and fog nozzle. We talked about automatic fog nozzles. We talked about selecting the proper hand line size. Most of the time for small residential structure fires, we're going to be pulling a cross lay, which is our inch and 3/4. If we have anything that is a serious residential fire or anything commercial, we're going to be pulling our 2.5. But like we talked about a couple of weeks ago, we always have that gust and pack that gives us kind of the opportunity to have both. We can pull that off the back, and we can have an inch and 3/4 to take inside the building with us. And then if the conditions change, we can break it and have a 2.5 inch to fight externally, right where we need it. So that's always a good option too. Talked about methods of fire attack, about our direct method, the indirect method that they talked about with using some fog and some steam generation to kind of cool off a room. Whereas most of what we do would be like a direct attack that may start as like an exterior direct attack on the fire, but um, we're pretty much just looking to fight the fire directly at the seed. Um, Fire stream types, solid stream, straight stream, and fog. The solid stream would be the same thing as a straight stream, with the difference is the solid stream is the only option you have on a smooth bore, whereas the straight stream is the terminology for the selected stream or a fog nozzle that's comparable. Positions on a line, you got your nozzle guy and you got your backup guy. Master stream devices and specialized nozzles, we talked about those, and then we talked about the care and the maintenance of nozzles. Okay, any questions on what we talked about tonight? Good, very good. Nice. Hold on, I gotta mute Zach real quick so I can hear you. Say no, ask that again. Yep, yep. Yeah, so I've been making that quiz manually, and so like after this class tonight, I will make the quiz for this class, and I'll post it in there as well. So tomorrow, I'll get that quiz made up, and then I'll post it in there, and then there should just be those two quizzes for now. Chapter 15 and chapter 16. So um, yep. And then so Tuesday will be our next training, and basically the plan that we're gonna have for that is because so now we've gone over hose loads, hydrants, nozzle stuff, and we'll talk about a little bit of nozzle stuff and a little bit of hose deployment stuff. Um, and then we've talked about getting off the truck. We've talked about getting all of our gear on our SCBA. Um, everything that we need to really do some evolutions. So we'll be doing some evolutions where we should have an engineer, an officer, and probably three guys in the back. One guy is going to hit the hydrant. Two guys are going to get a hose line. They're going to go to the door. They're going to get the officer is going to, do his 360. He's going to be working on what he needs, and then the two guys on the hose line, they're going to get masked up. Um, they're going to make contact with the officer. They're going to make sure that their hose is all bled out. Everything, all the pressure's set. The engineer's got all his pressures set. He's got the truck engaged in a good, timely manner. Everything's flowing like it should. Um, and then you guys are going to make entrance into the training center, and we'll have something set up to where you'll have to locate whichever room that the fire is in, and we'll be doing the same kind of sweeping the ceiling as we advance in there. Once we get to the fire room, then we'll do our sweeps in the fire room. We'll bring it back out and we'll kind of reset it and we'll go for it again. So we won't do any live fire, but we're basically going to do everything except for that live fire portion. That way, whenever we are ready to move on to the fire section, um, we don't have to, all this stuff that we're practicing on this Tuesday is all muscle memory, and the only element that we're adding is fire. So it's going to be a pretty important Tuesday of ours getting some good reps in as far as, getting ready to fight some fire in that building. So should be a pretty good situation, and it's going to be good for guys that need practice pumping the truck. A lot of our officers going to be good for our officers that need practice. So, doing size ups and running incident command. And then it's going to be obviously real good practice for all the guys that are looking to show up and hit a hydrant, fight some fire, advance some hose and stuff like that too. So should be a pretty good situation. Oh, I gotta take Zach off here. All right, still there, Zach? Sorry, I had to click to mute on you because I was getting some feedback. It's all good. Did you hear all that, Zach? Though? Okay, yeah, we can work on that. Yeah, yeah, yeah. But yeah, so let's see how Tuesday goes. Uh, hopefully everybody that wants to fight some fire has the opportunity. But okay, that's it for tonight. Thanks, guys. We'll see you around.